News from Cambridge Earth Sciences. Last July, the world watched as the Mars 2020 Perseverance rover took to the skies, setting out on its 300 million mile journey to the Red Planet. Nearly 7 months later, the rover is now approaching its final destination. The mission is an inaugural leg of a voyage to bring the first rock samples back from Mars. Once the samples are returned to Earth, scientists will get to examine Martian rocks in person for the very first time. They'll be looking for signs of ancient life and the early Martian environment in these rocks. My name's Erin Martin-Jones, and today I'm joined by Nicholas Tosca, Geoscientist and Professor of Mineralogy and Petrology in Cambridge's Department of Earth Sciences. Nick is the only UK scientist who has been selected to join the mission's core science team. Nick, hello, and thanks for joining me today.
No problem, it's my pleasure.
So this is really exciting news. Can you tell me, how did you feel when you first heard you'd be joining the science team?
I was, I was shocked and thrilled. Really, I mean, what could be cooler than being involved in in a Mars exploration mission? It's just an amazing opportunity. I remember I got the email early in the morning, my time, because it was sent from the U.S. and around the same time, my 5-year-old son was waking up. And I told him I'd be helping drive the Perseverance rover. And he said, "Daddy, if I'm allowed, can I come too?" and so since then, we've just been talking about it constantly, watching videos online, marking the landing on our refrigerator calendar, and actually making a cardboard rover. It's sort of in progress, but it's one of our lockdown activities. I guess the only other thing to say, surprisingly, is that I'm also a little bit nervous. I think it's because the role carries a big responsibility and obligation to my fellow scientists and to the general public. It's because we're going to be selecting samples that will be returned to Earth in one of the greatest, I think, international scientific endeavors of our generation, and we want to get it right.
Exactly, and it's lovely that you can share this with your son as well, and also that you're going to be one of the first people, the first scientists to just touch these rocks, right, and have a closer look at them, and that's so exciting.
Yeah.
So just following on from that, can you give us a little bit of a background to the Mars 2020 mission? Where is it going to land, and why is it going to land at this specific spot?
Yeah, that's a good question, and I guess a related question I get sometimes is, why are we going to Mars still? Haven't we been there before? And what are we going to learn that we don't already know? They're fair questions. This mission, I think, is special because it's been decades in the making. In a way, I think humankind's fascination with Mars has sort of been building to this point. I think part of it started in the 1970s when some of the first clear images of the surface were returned that showed features that could have been formed by liquid water. And so from that point on, I think it was thought that Mars may have, at one point in its very distant past, hosted liquid water. And then in around 2004, 2005, the Mars exploration rover discovered clear evidence for ancient sediments that were deposited in shallow pools about 3.5 billion years ago on the surface of Mars. And scientists think those pools were acidic and very salty, and so maybe they weren't the best place for life to have been preserved, although we know some very hardy and special microorganisms on Earth are known to live in similar environments. So I guess Mars exploration up till that point was, hit a critical moment, in that the key was really to look for a habitable environment, or a record of a habitable environment that was present at the surface. And when I say habitable environment, I mean an environment that could have been suitable for a range of microorganisms as we know them on Earth. And in 2013, the MSL rover discovered a habitable environment, which was an ancient lake deposit, and showed that all the essential ingredients would have been available for microbial life. And so NASA recognized that even though habitable environments did exist on Mars in its distant past, finding clear evidence of past life in those rocks is incredibly difficult. It requires special laboratories and complicated analyses that are almost impossible to do with a rover. And so NASA sort of doubled down and said, okay, for the Mars 2020 mission, we're going to go to an environment where we're reasonably sure a habitable environment was recorded. And we're going to select samples to eventually be returned to Earth so we can look for evidence of past life in laboratories that we have available to us on Earth. And that's really why this mission is so exciting, because it's the part of a Mars sample return endeavor. And you asked where we're going. So we're landing in a place called Jezero Crater. And Jezero is fascinating because from orbit, we know that there's a clear inlet channel and an outlet channel into this crater, that this big hole in the ground, suggesting that it was filled with water. And it was filled with water to the point when it then breached and overflowed through the outflow channel. And in addition, near the inlet, there's a spectacular delta deposit preserved, which we know from Earth tends to concentrate and preserve organic matter or material formed from biological activity. So the rover is equipped with some amazing instruments that will allow it to image the distribution of chemical elements and minerals and organic compounds in these sedimentary rocks to really help us aid in the selection of samples to be returned to Earth. I mean, one thing I should say is that at the end of the day, we don't really know what we're going to find. I mean, we have some clear hypotheses that we've already formulated that we'd like to test. But it's interesting, you develop a very different picture of a place from orbit, from data that are collected from satellites. And then when the rover lands and the boots are on the ground, so to speak, sometimes all of that goes out the window and discoveries can really change things.
I think that's what's exciting, isn't it? You just don't know what you're going to find, and you've got to go there with an open mind.
Yeah.
So you'll be building a picture of the early Martian environment from the rocks that you pick up from the Jezero crater. How does that work, and can you explain your role in the project, what you'll be doing?
Yeah, so as you said, my role is to help figure out what the sedimentary rocks at Jezero are telling us about the chemistry of the lake water, and also about the climate of Mars at the time that they were deposited. And I guess the way I do that, so I do that sort of research with sedimentary rocks on Earth to understand the details of Earth's climate and how that's changed over time. I do that by studying minerals, the minerals that are present in sedimentary rocks. And you could think of minerals as sort of natural chemical substances. We know that minerals can crystallize from a magma, but they can also be formed from chemical reactions that happen in water. And so they represent a really crucial record of the chemistry associated with the processes that form those sedimentary rocks. And knowing the chemistry of the water is really important because, even though water may have been present at the surface of Mars, it's the chemistry of that water that really matters a great deal in whether or not an environment was habitable or say had the right ingredients to support life. And as you said before, climate is part of the equation too. So we're interested in understanding what gases were present in the atmosphere. Was the climate stable over time, or did it fluctuate? And the climate of ancient Mars has actually been a long-standing problem for Earth scientists. The reason is that billions of years ago, I guess around the time that these sedimentary rocks were deposited, our sun was a lot less bright than it is today. And that's a problem for climate, in the sense that, according to climate calculations, most scientists think that the surface of Mars at that time should have been completely frozen. But of course, we know that it wasn't completely frozen. There's evidence for liquid water in many, many places across the surface. So I guess the question is, what warmed the Martian climate, even though the sun was dimmer? We know on Earth that CO2 is an important greenhouse gas. It generates a net warming effect at our surface. In fact, we worry a great deal about how CO2 levels in our atmosphere fluctuate today. And CO2 in Earth's atmosphere is only a minor component. The rest of our atmosphere is composed of nitrogen and oxygen. The problem, though, for early Mars is that even if you make the atmosphere 100% CO2, it's not enough to have warmed the surface. You end up with all kinds of problems of having so much CO2 in the atmosphere that you form CO2 ice clouds, and then actually reflects some of the incoming radiation back to space. So I guess the story with Martian climate is there have to have been other key greenhouse gases that were present that helped warm the surface. We're not sure what those were. And there are many basic details about the ancient Martian climate that we would love to know more about. And this mission also offers an opportunity to help understand some of those.
So the idea is that in these rocks inside the Jezero crater, they will contain the clues of that past climate, but possibly also the atmosphere.
That's right. That's right.
So, and this also connects to the habitability question, which we're also really interested in terms of life on Earth. Can you explain that link a little bit more?
Yeah, life on Earth. I mean, so we're interested in the evolution of life on Earth as Earth scientists. But in my mind, I think one of the biggest questions in science revolves around understanding the origins of life on Earth. We still don't understand how our only example so far of life actually got started. And this is fascinating. I mean, chemists are experiencing a revolution in understanding how the building blocks of life can be made in the laboratory. And that's crucial because it tells us that certain chemical conditions needed to have been met for Earth's origins of life. But we don't really know how they were met on the early Earth because we have no record of the earliest environments on Earth. So as we know, planet Earth has plate tectonics, which is a process that essentially destroys huge portions of the oceanic crust, and therefore most of our most ancient rocks. And so that's where the study of ancient Mars comes in. Preserved at the surface of the Martian, at the surface of Mars, is a record of environments that probably exist nowhere else in the solar system. So if we find out that Mars never hosted life after having a really up close and detailed view of some of those early environments, then that's incredibly important because it helps us understand what it was about our planet that was so special. But if it turns out that the ancient Martian surface did host life, it tells us that life, at least microbial life or microorganisms, really may not only have been limited to the Earth, and that's really fun to think about in the context of other planets, say exoplanets or the planets that we know now exist that are orbiting other stars in our universe.
So, yeah, scientists often say that you can read the Martian rocks like a book, don't they? And so, is that because of that preservation?
Yeah, that's absolutely right. The sedimentary rocks that are on the order of 4 billion years old, so formed when the planet Mars and Earth were both very, very young, are sitting right at the surface, and not much has happened to them over those 4 billion years. And it's like they've been preserved in a museum. And so when the rover lands and analyzes these sedimentary rocks, and we know this from previous missions, they look like they were deposited yesterday, and they're unthinkably old and provide a fascinating record of the early planetary environments on Mars.
It's incredible, and these rocks are really so important to building up the picture, and that's quite fascinating because you're obviously a geoscientist, and we often think of NASA missions as being kind of a reserve of planetary science. So what do you think the role is, or the place of geoscientists like yourselves in this mission?
Yeah, that's a great question. Planetary science in general and Mars exploration in particular have changed over the last few decades. And I guess all of what we've been discussing so far and the major questions I've mentioned up to now are squarely within the realm of Earth sciences. Earth sciences is really understanding how the Earth and other planets operates as a system. How does a planet's interior affect its surface and atmosphere? How did the atmosphere affect environments and water chemistry, on the surface of Mars and also on Earth? Would simple microbial life have thrived? And if so, where would it be preserved? And these are big questions. And in order to understand and attempt to answer questions like this in the Earth sciences, we call on physics and chemistry, biology and mathematics. And to me, that's one of the greatest things about being an earth scientist is that it's the home of big questions. Physics, chemistry, biology, and mathematics, they provide the tools for us to use, and we use them to address some of the most important problems facing humankind today. For example, like understanding how our climate has behaved in the past and how it will in the future.
So reflecting on that then, what do you think this mission means for future generations of scientists? What kind of opportunities might there be on the horizon for them, for instance?
Yeah, that's a good question. I've thought a lot about this from my involvement with some scientific planning groups for Mars sample return, and now also as a member of Mars 2020. And I think one thing that struck me is that Mars sample return, as we've discussed, is going to happen in our lifetimes. This is now a joint NASA and ESA effort to bring samples back from Mars, the samples that Mars 2020 is going to select, to bring them back to Mars by about 2030. And it's going to be one of the biggest international scientific endeavors humankind has ever pursued. And I guess from the standpoint of the UK, I think there's a tendency in the UK to have a feeling like we view what NASA does from the outside, when we're kind of looking in. It's very much cool USA-led stuff. Not this, though. This is very much an international endeavor, and the questions that we've talked about, and I think the stakes riding on this effort really transcend international boundaries. It's very much a human endeavor. So I think it's important for younger folks to understand that they could really get involved in this, and that there's a big role for the UK and Europe, both on the science and engineering sides. Because these samples are going to come back in our lifetimes, and we're going to be studying them for decades. I guess the last thing to say is that for students thinking about pursuing science, there's also never been a more exciting time to ask big questions about our planet and about others. That's one of the fun things about being at Cambridge. I mean, at Cambridge, we're forming an interdisciplinary research center that's really geared to helping students gain the tools to study problems like this and to become more involved. And it's really fun because it combines experts in exoplanet science, chemistry, and molecular biology, and of course where they intersect in the earth sciences.
And I wonder if we could just end maybe with some advice. And what would you say perhaps to young people watching this mission who might be interested in science, they might be interested in geoscience as well, maybe?
I think the advice would be follow the path that you find most interesting and most fascinating, and I wouldn't let any of the core skills and the things you have to do along the way deter you, because at the end of the day, the questions that we're pursuing and the opportunity to work on this has been so fun that you kind of forget that it's work, right? It kind of makes the process of learning the fundamentals of science and diving into these questions just so much fun. So I guess the advice would be to stick with it and don't be deterred when it starts to become opaque, which it will at times.
So I hope you enjoyed hearing from Nick there. Don't forget that you can also follow the Perseverance rover's progress on social media using the hashtag #CountdownToMars. You can visit the mission's website to find out more and even watch the landing live on the 18th of February, which is super exciting. And of course, if you're interested to hear more from Cambridge Earth Sciences, then please follow us on Instagram at Cambridge Earth Sciences, and you can visit our website esc.cam.ac.uk, where you'll find our latest news as well as information and guidance for prospective students.